Welcome to Master Mathematics in Minutes. Today's topic is the elimination method. We'll cover some examples on how we solve simultaneous linear equations using the elimination method. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So what is the elimination method? Given two equations with two variables, x and y, the elimination method involves Step 1. Combining the first equation with the second equation in some way. For example, we could subtract the first from the second equation. The idea is to eliminate one of the variables, call that x. And Step 2 involves solving for the remaining variable, call that y. And then we'll solve for the eliminated variable, call that x. Now I understand that there's a lot to take in, but it will help if we could look into a couple of examples, which we'll now do. In the first example, we're asked to solve the linear equations simultaneously using the elimination method. With x plus 10y equals to 20 as the first equation, and with 3x plus 5y equals to 7 as the second equation. So we'll need to inspect these two equations to look for commonalities. So in the first case, we can multiply equation 1 by 3, and it gives us 3x, which matches that 3x in the second equation. And we can subtract 1 from the other to eliminate x. So that's the first case. The second case is where we can multiply the second equation by 2. So 5y multiplied by 2 is 10y, which matches that term in equation 1. And by subtracting 1 from the other, we're able to eliminate y. So that is the second case. So in this example, we'll apply the first case, where we multiply equation 1 by 3. So with x plus 10y copied down, multiply that by 3, and with 20 copied down, again multiplied by 3. And we'll expand the brackets, where 3 times x becomes 3x, and 3 times 10y becomes 30y. And 3 by 20 gives us 60. And we'll call that equation 3, which is the first equation multiplied by 3. And notice that we have the common terms 3x in equation 3 and 3x in equation 2. So we could subtract 1 from the other to eliminate x. So subtracting 2 from 3 is where we have 3x plus 30y from equation 3 copied down, 3x plus 30y, and minus, because we're subtracting the left-hand side of equation 2, 3x plus 5y, copied down, 3x plus 5y. And we have the right-hand side of equation 3, 60, minus the right-hand side of equation 2, which is 7. And we'll copy the 3x and 30y. We'll expand the brackets, that is minus 3x and minus 5y. And so 60 minus 7 is 53. And notice that with 3x minus 3x, and that amounts to 0. And so we have eliminated the variable x, hence the name the elimination method. So 30y minus 5y is 25y. We'll copy the 53 down, and solving for y, we have y is equal to 53 divided by 25, and that is roughly 2.12. So we've solved for the first variable using the elimination method, and that leaves us with x, which is the remaining variable. So in theory, we could substitute y equals to 2.12 into any of these equations to solve for x. So substituting y is equals to 2.12 into equation 1, that is x plus 10y is equals to 20. We'll replace y by 2.12 from what we've solved, and bringing that term over to the right-hand side, that becomes minus 10 plus 2 times 2.12. And simplifying that gives us minus 1.2 as the x variable. And there we go. We have solved for both x and y's using the elimination method. So in the second example, we're asked to solve the linear equations simultaneously using the elimination method. We have the first equation as 2x plus y is equals to 50 as equation 1. And we have the equation 8x plus 6y equals 80 as equation 2. Again, we'll need to inspect these two equations. So the first case is where we could multiply the first equation by 4. So 2x times 4 gives us 8x, and that's a common term. And we can subtract 1 from the other to eliminate x. So that is the first case. And the second case is where we could multiply equation 1 by 6, and that gives us 6y, which matches that term in equation 2. And we could subtract 1 from the other to eliminate y. So we'll go with the second case, where we multiply equation 1 by 6. So we have 2x plus y copied down, and we'll multiply that by 6. And we have 50 multiplied by 6. And expanding the brackets, we have 6 times 2x is equal to 12x, and 6 times y is equal to 6y. So 6 by 50 is 300, and we'll call that equation 3, which is defined to be equation 1 multiplied by 6. So notice that 6y in equation 3 is the same as that 6y in equation 2, so we're able to eliminate that by subtracting 1 from the other. So we could subtract equation 2 from equation 3. So we have 12x plus 6y copied down from equation 3. And we will minus because we're subtracting the left-hand side of equation 2, which is 8x plus 6y, copied down here, 8x plus 6y. And the right-hand side of equation 3 is 300, and we'll subtract the right-hand side of equation 2, which is 80. And we'll copy 12x and 6y, and we'll expand the brackets. And that becomes minus 8x and minus 6y. And 300 minus 80 is 220. And notice that we have 6y minus 6y amounting to 0. And so we have eliminated the variable y, and hence the name, the elimination method. And then we're left with 12x minus 8x as 4x. We'll copy the 220 down, and we'll solve x, which is 220 divided by 4, and that gives us roughly 55. So in theory, we could substitute x equals to 55 into any of these equations to solve for y. So we've solved for one variable, and we'll need to solve for the second, which is y. So substituting x equals to 55 into first equation, we have 2x plus y is equals to 50, and we'll substitute x as 55. And we'll bring that term over towards the right, that becomes minus 2 times 55. And simplifying that, we have y is equals to minus 60. And we've solved for the second variable, y equals to minus 60. And there we go. We've solved for both x and y's using the elimination method. To summarize, the elimination method is where we're given two equations with two variables, x and y. And the first step involves combining the first equation with the second equation in some way. For example, we could subtract one equation from the other to eliminate one of the variables, say x. And we'll solve for the remaining variable, say y. And then we'll go back to solve for the eliminated variable, say x. Thank you very much for watching. This is Maths Mathematics in Minutes.